Hi, my name is Robin, and I'm from Online Maths and Accounting. And I thought I would let you have a bit of a sample of what it is that I do. I give extra online maths and accounting lessons to grade 7s, 8s, 9s, 10s, and 11s throughout South Africa. It's all done via Zoom, and it's great fun. So if you're interested, then please do check out the website www.dbkenterprises.co.za. All right, so what I thought I would do is I had a lesson with some grade 10s the other day, and we were covering the beginnings of trigonometry. So it was an introduction to trigonometry, and the lesson went really well. So I thought that I would let you have a look and see what it was that I covered with them. And then if it's the kind of thing that you think could be worthwhile, then I would suggest that the rest of my lessons would be worthwhile to you as well. So let's have a look and see. We're going to start with going back to basics, and then we'll pick it up and move further into trigonometry. Now, if you're anything like me, certainly when I was at school, trigonometry was a bit of a scary thing. And I guess that was due to the fact that either I wasn't paying attention in class, or that the teacher didn't quite get it through to me. But it was only a few years after that that I actually understood trigonometry properly. And so I hope that what I'm going to get across to you today will help you to understand it from the beginning, so that you can ace those tests and the exams coming up as well. All right, so let's just have a look at some triangles here. So trigonometry is all about triangles. Trigon is the old Greek word for triangle, and metry, or something to that effect, is the old Greek word for measurement. And if you know your Pythagoras, then you would know that this is a right angled triangle, and the theorem of Pythagoras says that the theorem of Pythagoras says that the square of the hypotenuse is equal to the sum of the squares of the opposite two sides. All right, so that's grade 8 stuff, or even grade 7 stuff. That shouldn't be too difficult, but there is a bit more that I need to get across to introduce trigonometry to you. All right, so we all know the theorem of Pythagoras. What we also know is that if this is a right angle here, then this angle plus that angle must also be 90 degrees, and then plus the other 90 degrees in the corner here is all adds up to 180 degrees. Okay, and then there's one last thing that I need to tell you before we can get really stuck into learning all about trigonometry. These two triangles here, the red one and the purple one, are similar triangles. Why? Because this angle is exactly the same as it was in the purple triangle. This one is exactly the same as it was in the purple triangle. And then obviously this one is also the same as it was in the purple triangle. The lengths obviously are not the same, but, and this is the key to trigonometry. The amazing thing about these similar triangles, and that's exactly why they're similar, is that not only are the angles exactly the same, but the ratios of the sides relative to each other, the ratios of the sides are exactly the same. All right, so I'm going to call this side here D, E, and that one is F. All right, so if I were to say, now ratios, you remember from grade 8, ratios are just a different way of expressing fraction. All right, or fractions are a different way, or a way of expressing a ratio. So if you were to say D over E, if you were to take the length D and take the length E and divide that, so D divided by E, you would get that it's exactly the same as A over B. The relationship is exactly the same. These numbers would be different because the lengths are different, but the relationship between those lengths is exactly the same. Exactly the same with, let's say, D divided by F would be exactly the same as A divided by F. And if you were to take a third triangle, a third similar triangle, and you would make it here, let's imagine a smaller one here. And let's give this the lengths G, H, and I. You would then find that G over H is exactly this. G over H is exactly the same as A over B, which is exactly the same as D over E. So G over H. And over here, let's just separate these two here. We said D over F, D over that hypotenuse, and A over its hypotenuse would be exactly the same as G over its hypotenuse, which is I. And those would give you exactly the same relationships or fractions. Okay, and that's all that trigonometry is. Now, the clever people out there have gone to great lengths to make it more complicated by giving it all sorts of Greek names and Greek ratios and all that kind of thing. And unfortunately, you are going to have to learn it. So the Greeks came up with the following 3 ratios to start with. It gets a little bit more complicated later, but we're not going to worry about that now. We've got sine, we've got cosine, and we've got tangent. Okay, and these are ratios. They are ratios of the sides of a triangle. Now, what I do need to tell you very briefly is that these ratios all depend on special names that we give to the sides of the triangle. So this is very important that you get this, because if you don't get this, it's game over and you're going to be lost from the word go. Okay, let's call this angle X and this one angle Y. Okay, the hypotenuse, you all know, is the longest side of the triangle, but more importantly, it's the side opposite the 90-degree angle. So that's the hypotenuse there. I'll just write HYP. You all know that that stands for, or is short for, hypotenuse. Now, when we're talking about angle X, when we're talking specifically and only about angle X, the hypotenuse is the hypotenuse. That doesn't change. However, there are 2 other sides, and the way we refer to this side here, looking far across to the other side of the triangle, this is called the opposite side. And when we look right next to the angle that we're talking about, this is called adjacent. Okay, adjacent means the same as next to, but obviously in trigonometry we refer to it as the adjacent side. When we're talking about angle Y, then all of a sudden we've got a different set of names for these sides. Okay, the hypotenuse stays the same. Okay, it's always the hypotenuse, it doesn't change. However, when we're looking for the opposite side, or the side opposite Y, we've got to look far out from Y. And so this side here becomes opposite for Y. And the side right next to the angle, which is adjacent, becomes this one, and that becomes adjacent to Y. So I might just fill in here, adjacent to Y, opposite to Y, and this one is, this side here is opposite X, this one, and this side here is opposite to X. Okay, Now, that's all a little bit messy, so we're going to start off here and say sine, the formula or the ratio that is defined by sine of any angle, and let's call that theta. That's a Greek sign for theta. Looks a bit like a grumpy face, but anyway, that's theta. That is opposite, the length of the opposite side divided by the hypotenuse. Okay, cosine of theta is defined as the adjacent side divided by the hypotenuse. I'll try and write it a bit neater now. There we are. And the tangent is defined, tangent of angle theta is defined as the opposite divided by the adjacent length. Okay. Now, what you need to bear in mind at all times is which angle are you talking about and which then is the opposite or the adjacent. And obviously the hypotenuse doesn't change no matter which angle you're looking at, but you've got to get the opposite side and the adjacent side correct. Okay, that's vital. So when you've got your triangle, if you're talking about this one, that's opposite and this is adjacent. But if you're talking about this angle here, this is opposite and that is adjacent. Assuming they're both right-angled triangles, then these are the hypotenuse for both. Right. Now, let's put some numbers to this and see how this all works out. Watch this. So we spoke about similar triangles, right? We've got this triangle here. That triangle has got a hypotenuse of 4. It's a right angle triangle. This is 2. And if you were to do your Pythagoras theorem, you would work out that this is 3,464 centimeters or units in length. And that triangle has got an angle here of 30 degrees. Now, if we were to draw a bigger triangle, also with 30 degrees, as this in this corner here, this vertex, we would see that this height now becomes 4. And this length here becomes 8, and this becomes 6,928. And if you work out your sine and your cosine and your tangent for 30 degrees, you will find out on your calculator that, that these ratios are exactly the same all the time. So, what you do need to remember, though, is, you know, I was never much good at remembering things. I needed to understand, but there are one or two things that you need to remember about trigonometry. Okay, so these formulae over here, you just need to remember them. Okay, I was hopeless at remembering that kind of thing, and so I struggled. However, somebody told me, and chances are you guys may have come across this as well. So ka toa. All right, so ka toa. Say it enough times so that you get it into your brain, and when you get into the exam or test that you know trigonometry is going to be covered in, then make sure you write that down at the very, very beginning of your test. Okay, just write it down because that's the key to your trigonometry. Okay, so what does this mean? Sine equals opposite over hypotenuse. Cosine, these are the abbreviations now, is adjacent divided by hypotenuse, and tangent, or tan, is equal to opposite over adjacent. That's all you need to remember for now, but you do need to remember it. Okay, you've got to remember it. So if we were to do sine of 30, we would say that's equal to opposite, and you can choose which triangle here you're going to do. Because I'm writing in red, we're going to choose the red triangle. Opposite, you've got to look far, so that would be 4, and divided by your hypotenuse, which in this case you've got to keep the correct triangle, is 8, equals a half. All right. If you were to take the blue triangles figures, purple triangles figures, you would look and you would see that the opposite side of this 30 degrees now is just 2 in length, and the hypotenuse is 4. And again, you would get to half. So sine 30, no matter what triangle you use, as long as it's a 30-degree angle in a right angle triangle, the ratios of the sides will always be in exactly the same ratio, which in this case for sine 30 degrees gives you a ratio of a half. Always your opposite over your hypotenuse will give you a half. And you can do that on your calculator. If you work it out on your calculator now and you type sine 30, you would see that your calculator would give you a half. And your calculator can work these out for any angle that you like. When I was at school, we didn't have the fancy calculators that you guys have got nowadays. And we had books. I think they used to call them log books. And these books used to have all the different angles and what sine of that angle was and what cos of that angle was and what tan of that angle was. And we needed to have to look it up. Fortunately, we don't have to live in those days anymore. All right. Now that you guys know that, you can work out all of these different ratios by simply putting the correct figures down for the adjacent side or the hypotenuse. It all depends on what information you have. But let's imagine that there's some information that you don't have. And this is one of the most practical purposes of trigonometry. It's one of the first things one of the main things that trigonometry was used for. Imagine you're on your rugby field at school, if your school's got a rugby field or a hockey field or whatever. There it is. And at the end of your rugby field, you've got your rugby poles. Boom, there they are. Okay, they're standing nice and vertical. Now, you obviously can't climb up to the top of that rugby pole with a tape measure to measure how high that rugby pole is. However, what you do know is that this is a right angle triangle. What you also know is that at the other end, you've got another set of poles. And in the middle here somewhere, this is a cross section of your field, you've got your halfway line. Now, if you were to stand on the halfway line, which I think on a rugby field is 50 meters, exactly 50 meters from your rugby poles, and you were to look up, let's imagine that that was looking up at an angle of 30 degrees. All right. Now, you've got two pieces of information, and our trigonometrical ratios or trig definitions carry three pieces of information. Let's go back to that quickly. There they are up there. Let me just neaten this up now for you a little bit. Here we are. Okay. So as you can see, your your ratios have got three pieces of information. It says sine equals opposite over hypotenuse. So that's 1, 2, 3 pieces of information. Cosine is the same thing, 3 pieces of information, etc., 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 etc. Okay, so when we're looking to see how high are those rugby poles, we're looking to see the vertical side of this triangle. How high is that vertical side? This one. Let's call it X. Okay. Now, remember your calculator can work out what sine of 30 degrees is. And in fact, we've worked it out already. But we'll do it again now anyway. But what we do know is that sine of 30 degrees, and this is always the first, very first thing that you should do when you're doing trigonometry here in a test or in an exam, because if you've got a generous teacher, they'll give you half a mark or a mark or whatever, even if you get the rest of it completely wrong, is to write out your formula. So sine, as we all know, remember, so Toa. Sine is opposite over hypotenuse. So I'm going to write there opposite over hypotenuse. And then I know that that is equal to opposite. Oh dear, we don't know that, but we do know that it's x. And that's what we're trying to find out. Over hypotenuse. We can't do that. We don't know that either. Okay. So we've drawn a blank there. Let's try another ratio. Cosine. Cosine of 30 degrees is equal to, cosine is equal to adjacent over hypotenuse. Adjacent over hypotenuse. Do we know the hypotenuse? No, we don't. So we're a bit stuck there too. Let's try the third one. Tangent. Tan equals opposite over adjacent. Opposite is x. Adjacent is 50. Here goes. All right, so tan 30 degrees equals x divided by 50. When you type into your calculator, let's get your calculator out here quickly. And I'm going to type in tan 30 degrees. And I'm going to get a number at 0,5773 equals x divided by 50. And now we just need to make x the subject of the equation. So to do that, I need to take that 50 to the other side. So it's 50 times 0,5773 equals x. X equals, in my calculator, 28,87 meters. There it is, 28,87 meters. We just worked out the height of the rugby poles on your rugby field. Now you're probably going to say to me, oh no, they're not 28 meters, they're probably closer to 15. I suspect that if you were to go out and stand on your rugby field, you would discover that that angle there isn't actually 30 degrees, but it's a little bit lower. But the logic is correct. Okay, so that's how you end up working out the heights of a building, a tree. This could be a mountain. This could be the tallest building in the world. It could be the height of a basketball hoop. You could work any height out as long as you know the distance from where you're standing, from where you're measuring it. That's that one at the bottom. And then if you can accurately measure the angle, they call it the angle of elevation. So when your eyes are at ground level, what's that angle that you're looking up at to see the top point of the thing you're trying to measure? So I hope that you enjoyed that introduction to trigonometry. There's a lot to it. It gets a little bit more complicated than that, but if you've got the basics, the rest follows on very, very easily. And so I really do hope that you found this worthwhile and that it helps you in your studies. And if you're interested, again, my website is www.dbkenterprises.co.za. And please do get in touch if you're in grade 7, 8, 9, 10, or 11, and if you need assistance in maths or in accounting. All right. Cheers. Have a great day. Thank you. Bye.